All right, YouTube, we're back, and it's Sage Monday. All right, so, boo, too bad. Do you remember this?
Yes.
All right, do it. Go ahead, do it in Sage. See what you get. Show the limit of. ln is log. Most high order languages use log for ln. Yeah. Okay. Many high order languages like Java and C use log for ln and use exp for e to the.
So I do log.
Philip, are you with us? Alright, so what'd you get? Don't use ln, use log. I don't know that ln is defined. They might have defined it, but log is what they use usually. You stuck? All right. Well, what did Lindsay Lohan say about this limit? Does not exist. Did you get that? Right. When it says infinity, it's that's a DNE. If it says positive or negative infinity, that means it's going up or down an asymptote. So like it's like a left-sided or a right-sided limit. All right.
I don't know if this means the number.
Well, what'd you get? You got infinity? What'd you get? You got infinity? I know. What'd you get? Well, that's a syntax there.
Oh, I did it.
Wow. Well, that would be that's a 90. You put show, does it be positive or negative? Oh, what's it? Oh, okay, you want to square it, right? You got to put that at start structure.
Oh, wait, but it has to be on the base.
Let's do it. No. Oh, element. That, the comma x equals 0 is angle. You want to do it? I guess infinity. Well, that's why you didn't have a show, is that why?
Me?
Yeah, you didn't have a show, is that why I said infinity? Yeah. No. Yeah. All right. It doesn't recognize that's this. No, not you.
Yeah.
What is wrong with her code?
Jay, you have extra school. Sydney wrote mine.
Yeah.
Well, that would
I don't think anyone did it correctly. Did you do it right?
Does it not know that Max is
Oh, we were supposed to do our names too. Oops. What date is it?
Imagine more like hot dog with log.
Let's see what I come up with. 23rd. All right. Oh, is this Paris?
Yes.
Okay. What number you got? You got the right number. There it is.
Do you have clear tape?
All right. Who didn't get infinity?
I didn't know how to do it.
No. All right. Let's do it.
Did you have it over me?
I did not.
Stand up for yourself.
All right. So where is my Sage cell? There it is. Okay. So I'm gonna also graph this thing. So I'm gonna define it as a function before I take the limit? All right, so what is it? The numerator and the denominator, right? All right, the numerator was what? Log of 1 minus x, right? And then minus sine x. Okay, that's the numerator. The denominator is 1 minus the cosine of x, quantity squared. Well, just the cosine is squared. You can use caret or you can use star star. Now, the limit they want at 0, right? So show the limit of f of x as x approaches 0. And many of you got infinity, in other words, undefined. There you go. That's a DNE. Yeah. Why not what? You can, but the thing is, I want to graph it and show why it's infinity. I don't want to have to type it again. So let's graph it. Now remember, I don't know if you remember, but x min and x max default to -1 to 1, and since we're interested in the limit at 0, this should do fine. Let's see what this graph looks like. Let's see. So is it clear that at 0 craziness happens? As x approaches 0 from the right, what's y doing?
Huh?
As x approaches 0 from the right, what's y doing? Going to negative infinity. As x approaches 0 from the left, positive infinity. So when it says infinity, that's just DNE. But if you say a direction, comma, dir equals, quote, left, then we say from the left it would be positive infinity, right? Let's see if we get that. There it is. And for fun, if I copy this and put it over here and make it from the right, I should get negative infinity. Alrighty. And I do. There you go. So if it just says infinity, that's a DNE, it doesn't tell you much. If you're doing from left to right, then it's telling you if it's going up or down the asymptote, right? Okay. All right. Don't forget to put your name at the top. Go to the beginning of the first line, hit enter, make room if you need it. If you didn't do this already, put your name, put the date, and put the topic. What is the topic today? The topic is, I guess, Mean Girls. Okay. All right, who's stuck now? Did I type it? Well, you didn't have to do it. What else? No? Did you like retype it? Maybe you fix it or retype it? Yeah. All right, you didn't have to do it that way, but I didn't want to type it for like 10 times.
Why don't I get in trouble?
All right.
Wait, can you tell me this?
All right, who's stuck? Are we stuck? Like to see positive and negative infinity and graph.
I got the next. Oh, then maybe I have it.
Say what? You won't mind. You what? You what, buddy? Henry. Is that back? Yo, Henry Davis Phil. Yeah, Henry. If you were to make it Phil, you have to be better than that. And he'd still get no credit to run stars or something like that. And he would still get no credit.
All right, everyone good?
About the credit,
Who
man.
doesn't have these three
Remember
out?
about the credit. It's about fraud.
You good, you good, you good?
We have pride, we still get credit though.
So Gabe, we're making it, Philip. You think I'm joking? No, we're doing a Philip.
Wait, when do you want to do the project?
I don't care about project. I care about.
You want to do it Wednesday?
Yeah, I don't know. We have to do it this. We have to finish it this week.
Are you free Wednesday?
After
Or do you
6
just want
o'clock.
to do it Friday? Or I can't do it Saturday.
We're gonna do it after 6 o'clock.
We're gonna get these three outputs.
Wednesday?
Me who?
He's like, I'll be home like 6.
Dude.
Nick, are you free
You,
Wednesday?
me too? Me too? You?
After 6?
Cause
I guess we'll just
I
go
go.
on
I
the
work.
Google Docs.
I work every day after school, so but I'm home like 6:30 after school every day. So working. Well, not like today, but tomorrow. How are you doing today and tomorrow?
Alright, anyone else stuck? We're all good? You got it?
Yep.
Everything got it? Okay. Alright, now, what kind of limit is this? Yeah, but it's an example of what? Isn't this a L'Hopital problem? Because if you plug in 0, what's 1 minus 0 in the ln? 1, and ln of 1 is 0. Sine of 0 is? No. Sine of 0 is 0. Cosine of 0 is 1. Wow. The AP was only a couple weeks ago. Alright, so you got 0 minus 0, the numerator is 0, and the denominator, what do you got? You got cosine of 0 is 1, and 1 squared is 1, and 1 minus 1 is 0. So it's 0 over 0 case, meaning time to do L'Hopital. So let's do L'Hopital. All right. So let's see L'Hopital. So what if we L'Hopital the top? Let's do the L'Hopital thing like this, okay? How about show the diff of the numerator? Remember what L'Hopital says, right? Differentiate the numerator separate from the denominator. Okay, so there you go. With respect to x. And then let's do a show diff of the denominator with respect to x. I don't know if you noticed last time we had a couple of, what do they call, deprecation warnings, that you used to be able to leave out the x and would figure it out, but now it's saying don't do that anymore, so I'm putting it in. All right, so let's see. Notice the plot will go away to save paper because I don't have a show there. Now, what is the derivative of the top? All right, let's see so we can fit this all on one screen. I won't be able to see it too good. All right, so the derivative of the top is 1 over x minus 1 minus cosine of x. Is that right? What's the derivative of ln of u? 1 over u du, so 1 over 1 minus x times negative 1. Is that what that is?
Sure.
1 over 1 minus x and then change the sign? Yeah. And then the derivative of negative sine is, derivative of negative sine? Is it negative cosine? It is, right? Okay, what about the denominator? How'd they get the derivative of 1 minus cosine of x squared is 2 cosine sine? Oh, did I put it in the wrong place? I put it in the wrong place. Inside the diff, comma x. Okay, we had deprecation warnings when we didn't have the comma x, either in the diff or in the integrator. I forget which, one of those. All right, let's check that. Now the derivative of 1 is 0, and derivative of stuff squared is 2 stuff to the 1 derivative of the stuff. That's right. Okay, now pretend that's a fraction. The numerator is 1 over x minus 1 minus cosine x, and the denominator is 2 cosine x sine x. And L'Hopital says plug into 0 again, right? But right away you see the denominator, bad things happen. Why? What's the sign of 0? So the denominator is definitely 0. So what does that mean? If the numerator is not 0, we've got undefined. If the numerator is 0 again, what do? L'Hopital it again. Okay, what's the numerator if you plug in 1? I'm sorry, not 1. They're plugging in 0. So 1 over 0 minus 1, what's 0 minus 1 in the denominator?
Negative 1.
So you got a negative 1 minus cosine of 0. You got negative 2 in the numerator? Yeah. So it's negative 2 over 0 means undefined. Remember, as soon as it changes from 0 over 0 in the L'Hopital case, you've got an answer whether it's defined or undefined. This one's undefined, 2 over 0. Alrighty? Good. That was good. Yeah.
I got a syntax there.
Okay. Alright, good stuff, good stuff. On the diff?
Yeah.
one says 706.
Exactly.
How you include that?
Familiar option.
That green will be in there. So, yeah.
It's literally the familiar option.
Oh yeah, I got that when I took this one. That's weird.
It gets crazy when it goes on
That's a
the
lucky man for
I don't get that.
Yo, if you heard that song, you know, like, people who've heard it.
Well, I know, but it's because we don't have a show yet.
No, so you know that song. That song's been around for a good 3 years. You know, if you rock it, it's GS9. With the GS9. Oh, is that fucking Brick Squad? Yeah. Oh, GX9 from Upper. So hard.
Oh, you got it, this whole thing is a lot, right?
What are you looking
Yeah,
for?
you don't want that. All right, get rid of that.
Million lot. The first one. Here, so nearful.
And that's
Yeah, the first one's the original. Second one looks like the remake. Yeah.
Alrighty, so
The first one.
now remember this problem? The limit does not exist because when we did L'Hopital to it, the first time we got 2 over 0. And we were right, yes. Okay, just confirming our answer. All right, now.
Print it.
Is this a good time to print? Let's see.
Yeah.
You know, this is a good time to print. Okay, make sure your name's at the top. Control P, enter.
You want us to keep the graph or make it a comment?
Well, the graph shouldn't be showing at this point. I don't have a show on line 5, do you? If you have a show on line 5, just get rid of it and evaluate it again. I mean, I like graphs fine, but they take up a lot of paper. So we're not going to put that. Yeah, just get rid of the show. I don't have a show on line 5. So we saw it when we did line 5, but then it went away when we did line 6. All right.
Wait, can you scroll down? So I can see if I have that?
Okay. I mean, scrolling up, right? The scroll is the paper's moving up. That's the output you should have, yes? The scroll wheel is going down, I guess, but that's an artifact. Okay. Alrighty. So everyone has that and everyone printed? Okay. You don't have to get the print out because it takes forever on the Windows network itself. Alright, so let's take a look at this other example. So now you're ready, you know how to do everything, limits and derivatives and integrals and factoring and solving and graphing. And remember, what are the 4 things that your calculator has to do for the AP, part 2A? Right? What does your calculator have to be able to do? Graph in an arbitrary window. What else? Math? Yeah, I think let's do a little bit more specific. 3 numerical solutions. Solving equations, graphically or numerically, right? See where they intersect, that kind of thing, right? What did you do?
It froze.
You did?
Right after I clicked print.
Okay. And what else? Get a numerical derivative or a definite integral, numerical integral, right? Well, you know how to do all of that on Sage already, so you're ready to do some free response questions, aren't you?
No.
Oh, yeah. Woo! Do you remember this one?
Oh yeah.
Fearless leader, dirty deeder, chief reader, Rosenstein. Do you remember that question?
Yeah.
Yeah, it's right here. So let's do it. Can we do this free response question in Sage? All right, let's see. 8886. Let f be a differentiable function defined for all real numbers x with the following properties. F prime is ax squared plus bx, and f prime of 1 is 6. F double prime of 1 is 18. And the definite integral from 1 to 2 between f and the x-axis is 18. Can you figure out what the heck f is? All right, so what would you do first?
Integrate A, I mean 1.
Integrate? Yes and no, but yes if I knew A and B. But I don't know A, B, right?
You're gonna find A.
So I'm going to find A and B first.
Plug in 1 plus 6.
Plug in 1 into f prime. Okay, so what does that give you? 6 equals A plus B, right? If you plug in 1, f prime of 1 equals 6 means what? Plug in 1 for x, right? And 6 for f prime. So that would mean 6 equals A plus B, right? Is that enough to figure out A and B? No. Let's use f double prime of 1 equals 18. How do you do that? All right, so what if we make F. What if we make in Sage? I'm going to call it. Well, what would you call it? F for F prime or FP maybe? I don't know. You're going to call it something. All right. It's AX squared plus BX, right? Okay. So let's write that. So all right. Let's start over again. We can just clear out all this stuff. We printed it already, right? All right. We're not going to print this anyway. But this is 88AB6. Just for fun? Okay. So what if we let FP equal? How about that? For F prime, just to give it a name? Okay, A times X squared plus B times X. Remember, you have to say times when you mean times. Where's times?
Wait, won't it not know what A and B are?
I was just going to say, is there a problem with that?
Yes.
Yeah. So if we tell it to differentiate that, there's going to be a problem because it doesn't know what A and B are as...
Bar.
Oh, I printed this to the wrong thing. Okay, whatever. We're gonna figure out this problem.
Bar A, bar B.
Do you want to var it? Well, okay, just for fun.
Bar A.
What if, okay, what I want to do with this is figure out F double prime, right? Call it F double P for fun. How are we going to get F double prime?
Diff.
Diff of who? Of FP, right. I'm just calling it F. You can call it anything you want. I'm calling it FP to make it clear which one's F prime and which one's F double prime. All right, and now if I tell it to show both of these, just to make sure I got them defined correctly, you're going to find that there is a problem with the A and the B, right? Let's see. So right away it says A is not defined. Okay, so how do you fix that? Okay, so let's do it right here. Var A. All right, so now what? And now it doesn't like B, right? Okay, so comma B. You can list as many variables here as you want. All right, so let's see. Did we get the right thing? If AX squared plus BX is F prime, is F double prime 2AX plus B? Yeah? Okay, now, they're telling us about F prime at 1 and F double prime at 1, right? Okay, so rather than showing F prime of X and F double prime of X, how about F prime of 1 and F double prime of 1? Okay. And now, what do they say? That F prime of 1 is 6 and F double prime of 1 is 18? Is that what it said?
Yeah.
It did, right? So how are you going to use that information to solve for A and B?
Well, if we know that 18 is equal to 2A plus B,
Uh-huh.
solve for each of them. 'Cause that's
Okay.
proportional.
So solve. Yeah, but I'm going to let Sage do the work.
All right, yeah.
Solve A plus B equals 6. What? What's this equals stuff?
That's when you put it in a loop.
Equals is Boolean. It's either true or false. The solve command is going to try and make it true. Single equals is in the Simon statement. If I say like x equals 2, it changes the value of x. It stores 2 into x, right? That's different. I don't want to store 6 into A plus B. All right. Comma 2 times A. Where's my time scheme? Times A plus B equals 18. Now, if you're solving more than one equation, you have to make it a list, put it in square brackets. And then you got to say what you're solving for. A and B. Okay. All righty.
Wait. Don't go. Where am I?
All right, so this is a solve command. We haven't played with the solve command before, right?
Right there. I thought you said we knew everything.
Well, I lied. All right. Oh, I didn't do a show, so it doesn't look pretty. But A is 12 and B is -6. Now, if you don't do a show, it does what's called a print. And a print is nice if you want to cut and paste this and put it into your code. But we're not cutting and pasting, so why don't we make it a show after all? Show it. Just to make it look nice. Come on, today. There you go. So A is 12 and B is -6. So now what? Well, now let's do what you wanted to do in the first place. If we knew what A and B were, to get F from F prime, what do you do? Integrated, right? Okay, so apparently, what did we get? A is 12 and B is negative 6? Okay. So if A is 12 and B is negative 6, we're integrating 12x squared minus 6x. Is that right?
Yeah.
All right, so let's do that. All right, so where am I? So let's do a show. Integrate. All right, so let's write that. It's going to be 12 times x squared minus 6 times x with respect to x. Alrighty. All right, there you go. Now notice what the integrate command does not do. I'm just a constant, nobody loves me. Remember that song? No, you don't remember that song? The Bohemian Calculus Rhapsodies thing? Okay. Calculus Rhapsody? I don't know, whatever it was called. All right, so we don't have a plus C, right? We should have a plus C, right? Okay, so how are we going to get the plus C? Well, look, no, I mean, what are we going to use here to get the plus C? Let me say it that way. This piece here, right? So we're going to take our answer that we just got. What the heck was it? 4x cubed minus 3x squared. And we're going to put a plus C after it and integrate it from 1 to 2, set it equal to 18, and solve for C. Aha. Okay, so let's do that. So, where am I? So,
But don't you have to integrate twice?
right, this is already integrated once. We started with f prime. We integrated, we got f. This is f with a plus C. Then we're going to integrate again from 1 to 2 to figure out the C. Okay, so how about we do this? Let's call it, I'm going to call it f. F is the function they want us to get, right? F of x apparently is 4 times x cubed. I probably should have not done a show, so I could just cut and paste this piece. Times 3x squared plus c, right? Or you want to make it a capital C? Well, it's case sensitive. I'm not going to do that. Okay, now what if I show f of x? What's going to happen? What happened? Doesn't know C. Okay, so let's put a C up here.
Mr. G,
Yeah,
for variable, can you make it more than one letter, perhaps?
I think it can, yeah.
Okay.
Yeah. All right, so that's the thing I want to integrate, right? I want to integrate that from 1 to 2 and set it equal to 18. Okay, so let's do that. Show the integrate of f of x with the plus c and all that. Dang it. With respect to x from, well, if I just do that, what do I get? What happened? Is that what I wanted? No, that's the definite integral. What do I want? Indefinite integral from 1 to 2. Oh, okay, so comma 1, comma 2. Okay, c plus 8. Okay, now what did it say about the definite integral from 1 to 2? What did it say about this? We just calculated? 18, right? So guess what c is? C is 10. Ta-da! Okay. So you're done. C is 10. Okay, if you really want to be crazy about this, show the solve of c plus 8 equals 18. Let's solve it for c. That's sort of crazy, but there you go. You get c equals 10, right? And then if you show f of x, does it put it in there?
It says C. Name C is not defined.
Well, we defined it.
You have to put it in bar.
Did we put it up here? Did you put it up here? Okay. Now, what if I show f of x? Does it know that we figured out c? No?
I don't think it does.
I don't think so. No, it didn't. All right, so such is life. But we got, all right. How are we going to write this? Just to state the final answer, right? You got to state your answer, don't you? What did we figure out? It's at 10, right? Dun, dun, dun. There you go. All right, there it is. F of x is 4x cubed minus 3x squared plus 10. All righty. So, shall we sing? Dirty Dieter, Archie Frieder, Rosenstein. You're a hero, you gave 0 to a kid you thought was 9 in a classroom in Topeka on the 13th day of May. Set the class of Mrs. Bentley for their AP Judgment Day.
After months of AP homework, Betty Sue was well prepared.
All right, it's there. She moved quickly through the problems, never nervous, never scared.
86 was tough for some, but Betty Sue was feeling fine. As she smugly wrote her answer, she was sure she had a thing. Then the tests were wrapped and bundled and were sent to ETS, where a group of expert graders would do justice, more or less. In the world of mathematics, sometimes things are meant to be. So alas, at George's briefing, Betty Sue was sample G. All the readers at the briefing gave her 9 with pleasure when they could see she had 4x cubed minus 3x squared plus 10.
Which is what we got.
With displeasure
And his head just gently shook. Then he sighed, that's not what I had, so let's take a closer look.
in the third line, she had F prime when she wants to integrate. And she never quite recoups it, so she can't get more than 8. In the fourth line, she miscopies, and 12 becomes 11. I'll admit that it's a pity, but her 8 just fell to 7. Now she sees that it's 11, but her 8 is needle hurts. So she changes to match it, that's too bad, she's down to 6. Then she puts those terms together for a function to derive.
But a plus becomes a minus, so she drops from 6 to 5. Then she integrates quite nicely. But we thought the kid was 4. For her C is clearly missing, and her 5 is down to 4. All right, that's good enough for today. All right, tomorrow's Movie Madness, and Wednesday we're doing FRQ's 2016 BC. It froze again. All right, I'll have to look at it. All right, thanks. All right. Okay, bye-bye, YouTube. Have a nice day.